Hey PCHEMers, this is DW, and I just wanted to give you a quick rundown on the types of answers I expect whenever you're given a discussion question. My main goal is that you actually need to convince the TA or myself that you actually know what you're talking about. And one way to do that is to use the vocabulary that we've been studying, use it correctly, and be specific about what you're saying. So let's look at what works and what doesn't in terms of your answers. So here's an example of an answer that really should get 0 credit. So this is on the lab that you're working on this week, and it says here if you anchor the cells correctly, etc., the chart should resemble the n equals 1 and 2 wave functions. Change the n values to see the chart change, and we only have 10 divisions in our box. The wave function will be inaccurate at high n values. What n value is too high in this spreadsheet? Also, do the symmetry rules work out even times odd, etc.? And so here's the student's answer that I would consider inadequate. I changed the quantum numbers and the wave functions changed. Do you see how that's not really saying anything, not anything specific, and certainly doesn't tell me that you understand what's going on? Yes, the wave function has changed, of course. That just means your formulas are working, but it doesn't tell me anything scientific. The wave function disappeared at n equals 10, but came back at n equals 11, and the symmetry rules worked out. I mean, you've addressed all the different things I've asked you to do in this problem, but you haven't convinced me that you know what's going on. Why did the wave function disappear at n equals 10? Is that the place where it becomes too high? What can you say about this that's specific? So let's look at a good answer. Specifics matter. So here's this answer. I'm going to zoom in on that. And so here's an adequate answer, actually a good answer. I changed the quantum numbers and the wave functions resembled the smooth wave functions in the class notes. Notice you're actually evaluating what the wave functions look like. You're not just saying they changed. Anybody can say they changed. This tells me that you're acknowledging that the ones in class were smooth and these resemble those. They're not as smooth because we only have 10 increments in our box. Next sentence. The quantum numbers produced wave functions with the expected number of nodes. Okay, so this is telling me this student understands that the nodes should increase. And in fact, in parentheses, I put n minus 1 nodes. So whatever the quantum number is, it should have one fewer node. So that's a great answer. They're telling me they know something about the wave functions. And then they say this happens up until n equals 10. And then they evaluate what's going on at n equals 10. They say every node hit every data point that we were plotting, so the lobes disappeared. The wave function disappeared at n equals 10, but came back at n equals 11. However, the number of nodes were inaccurate for n equals 11 or higher because we don't have enough increments in our box. If you look at the wave function for n equals 11, it does not have 10 nodes. It can't because we only have 9 data points in between the ends of our boxes. And then they go on to the symmetry part. The symmetry rules of multiplication worked out, showing that E times O equals O. So I'm assuming that means even times odd equals odd. And they sort of put all of the symmetry rules here. And then I say, however, some of the higher quantum states failed, like 1 times 9 yielded NA instead of even. So this is a very specific answer. Has a lot of detail. It's putting in little tidbits that tells me they know what they're talking about. So this is what I'm looking for in your answers. I'm not looking for you to just go through and say things like the wave's function changed or the peak got bigger. Tell me why you came to that conclusion and what do you think it means. Here's the strategy for written work on an exam, on a lab, and so on. Most students in general feel like if you write more words, your score will go up. So this is a linear relationship. More words equals a higher score. That's not true. This is more likely the case. So if you go on and there's a certain amount of words and you kind of reach a peak and then it starts to taper off. Early on, if you start with too short of an answer, you haven't convinced me that you know what you're talking about. There's a sweet spot where you've demonstrated that you know what you're doing, and that's when you need to stop. If you go a little further than that, you're starting to show some insecurity because you're shotgunning things. You're putting in all kinds of things that you can remember, but you really don't know why they apply to this situation. If you can apply and explain why you're going there, that's good. But eventually, you've written so many wrong things that you'll lose credibility, or you've just shotgunned a huge response to something that's fairly straightforward. So you want to aim for this middle region. You want to give me enough words and enough specifics so that you can convince me that you know what phenomena, what science is behind that discussion question. So hopefully that'll help you this week on your lab reports, and also on your exam questions, and anytime you're asked to discuss something in PCHEM. All right, talk to you later.